Hey guys, this is Mr. Sal. This is the homework for 10.1, just some of this statistic stuff. Thanks for watching. Don't forget to subscribe, like, and comment below. Catch you guys later. The campaign in Jelly Bean Town actually began in March with the election in November.
Oh, we did this one.
The plots below represent surveys taken during the election process in March, August, and October. Each plot shows the results of 20 different surveys. So there we go. We got March right here, August, and then October. In March surveys, circle the dots on the graph where grapey bean and limey bean were tied. Based on the graph, who was ahead in the campaign in March. All right, let's go ahead and look at these. We'll circle the ones that show a tie. A tie indicates that you have the same number of votes for limey as well as grapey. And it didn't show the 5 right count, but they could have. Those dots right there represent a tie between grapey and limey. So, looking at the distribution of these. Alright, so we can see that if we looked at just the distribution of these, it would look maybe something like this. And just because it's split down the middle here with 5, we can see that there's a lot more over here in this area than there is for this one right here. So this one has a lot more space in the graph than this one. So it's distributed more towards the left, which is less for green, and green was for limey. So this one indicates that grapey are winning. Next up, we'll look at August. We'll circle the dots on the graph where grapey bean and limey bean were tied again, and then we'll determine who we think is winning at this point. So start this one off. Again, we're looking for 5, which would be 5 votes for limey and then 5 votes for grapey. Alright, so 5 would be this column of dots right there. All 1, 2, 3, 4, 5, 6, 7 of them. And again, that kind of splits the chart, which then allows us to go in here, if we can find the distribution of this chart. And then if there's any unevenness, then we can determine who's winning. So just by looking at this chart, it kind of comes up this way and then down a little bit like this. Now, there's a couple answers that would be acceptable right account. It looks like there's more dots on the left, which is good for grapey. Right, these ones would be good for grapey. Whereas these ones on the right are better for limey. And so you could have said perhaps grapey is winning at this point. But if you said that it's more like a tie, because there's a high number in the middle, that would be fine as well. Alright, the next one. In the October results, circle the dots on the graph where grapey bean and limey bean were tied. Again, we're looking for 5. So we'll circle those dots. Actually, it's just a dot right here, which again kind of separates the data like these. This one, of course, is heavy, very heavy, towards the right side right here. So that would indicate that there's more of the greens were voting there, which means that limey is ahead in this campaign in October. Alright, based on the plots, is it possible that grapey bean could be ahead in the campaign in October? Oh yeah, it would be yes. There's a difference between what is probable and also what is possible. Very different. Grapey bean isn't going to let limey bean win the election based on a catchy slogan. And the week before the election, grapey decides to fight back by promising more coolness, less darkness. Yeah. Oh yeah, man. Yeah. Grapey bean quickly recruited several expert survey teams to sample the Jelly Bean Town population in hopes that the new slogan will turn the tide back in grapey's favor. So after advertising grapey's new campaign slogan, the 3 different survey teams gathered data and plotted their results. There is one plot for each survey team. Was grapey bean's slogan successful? Will grapey Win the election now. Use the combined results from the 3-team survey to justify your results. Well, it is possible that we could look at all 3 of these and determine what the results would be, but instead of having all 3 of them separate, it may be helpful to combine them. So let's combine these. Alright, so that's what I get after I combine this chart over here. Next up, we'll combine these. Alright, so we combine those ones. So this is our graph right here. Looking at this graph, who do you think is winning just based on the distribution of the chart when we combined them? Now, if we were to look at this, there's a lot more values on the left, which is bad for Limey. So at this point, did the slogan work? It appears that it has. So will Grapey, was this slogan successful? Yes. Will Grapey win the election? At this point, we're looking at it probably. And the reason is because the sample showed less votes per sample for Limey, which means it's heavy towards the left, or there's more dots on the left, which is bad for Limey. More to the left of 5, really. Alphabet frequency. So we have these 2 graphs right here. The 2 bar graphs above represent the frequency that letters occur in 2 languages. One graph represents the English language, the other represents the Spanish language. Number 1, which 3 vowels and 3 consonants occur most frequently in the language represented by graph A? Alright, so we do need to include consonants on this. So let's just identify the 3 vowels that are the highest. And right here we can see that's A, E, and O. And then the 3 highest consonants, looks like is S. The next highest probably R, right here. And then the next one, L, M, this would be N right here. So we've got the vowels in orange and then the consonants in red right here. And the highest of all of them is the vowel A. And, oh, it's not A, it's E. Then the next highest is A. Then the next highest is still a vowel, O. And then the next highest appears to be S. And then Q, that's R, looks like it's a little bit higher than N. So that's why in Wheel of Fortune they give the people the letters R, S, T, L, N, E. Which 3 vowels and 3 consonants occur most frequently in the language represented by graph B? Write the letters in order from most frequent to the least frequent. Alright, let's identify our most frequent one, that's E. It looks like T is the next one right here. That's a consonant though. And then the next highest appears to be A, which is a vowel, so we'll keep that in orange. Next up, L, M, N, O. That's another vowel, so we've got our 3 vowels already. And then maybe I, but that's a vowel, so we'll skip it and move on to what appears to be N. And then it looks like S is the next highest right here. So to start with the highest one that we have up in here, that was E once again. The next highest is T. The next highest was the A, that's a vowel. Then it was O. And then we move back to the consonants, looks like N and S. Use the graph, estimate the frequency of A in each language, find the difference between the 2. So we'll start with graph A, and then we will also look at graph B. Find the difference between the 2? Sure. So right account in graph A, this one is just a little bit beyond 0.12. It doesn't look like it's halfway up there, so it's not 0.13. Maybe about 0.125-ish. And then B, A happens just a little bit more than 0.08, so maybe 0.08. I'll say that's about a quarter up there. 25. These are my estimations. You should be pretty close to these though. Okay. So this is graph A. The halfway point on these is about right account, right? And if we split that up, that'd be 0.13. And this line is about halfway from 0.12 to 0.13, which is why I put 0.125. Then for graph B, same idea. If I cut this in half, that'd be 0.09. Cutting that in half puts us just a little bit higher than that mark right there. So that's 0.085. So I need to cut it even further in half, which would be 0.08. Half of that is 5, half of that is 0.25. The most frequent word in the English language is the word the. Based on that hint, which graph A or B represents the frequency of the letters of the English language. Now, I know at least one of you guys speaks a different language. Alright, that's very good. Now, they did give us a hint right there as well, down here at the bottom. The is the most common English word. So, that means that T, H, and E should be high. In graph A, right account, we can see that T is lower here than this T is, because that T is very high. Same with H. This H is low. G, this H is extremely low. This E is high, but so is this one, so that may not be as helpful. Both languages use E quite a bit. I don't know, I'm not familiar with a lot of Spanish, but I don't know that I've heard a lot of K's in the Spanish language, which is why this one is so low. The bar graph below is a sample of the frequency of letters used in the first two paragraphs of the book Artemis Fowl, the Last Colony by some dude or lady, I don't know. Since the graph is from a sample, the frequencies will vary a bit from the overall letter frequencies in the English language. Compare the book samples to graphs A and B. Which graph is the book sample most similar to, A or B? So which graph does this one appear to be the most similar to, Radical? Well, it's got a high E value, it's got a high T value, and a high S and R. It's pretty good. Kind of looks like graph A.
I think graph C.
But also a little bit of graph B. It's kind of a tough one.
Yeah, I think
It kind of looks like it could be maybe
It looks like
either.
E.
Alright, if we look at that type of pattern, that's true. It goes more of a down upwards, down upwards, down upwards, down up, and then just kind of levels out. Graph B seems to be more similar to this, especially where Radican goes down, up, down, whereas this one it goes, I guess down, up, down still. Maybe it's not accentuated as much though, like it is in B. I was looking more at the T and the S values. This T is separated more from the S Radican, whereas this one is not as separated. So yeah, I would say graph B myself. Cryptograms are puzzles where a symbol or letter is substituted for an actual letter. Each of the Artemis Fowl books has a cryptogram at the bottom of the pages of the book, where symbols are substituted for letters and readers are challenged to solve the hidden message in the cryptogram. One way people find clues in cryptograms is by looking at letter frequencies. The three most common symbols in order from the book Artemis Fowl, The Lost Colony, are shown below. Which letters do they likely represent? And they did give us some hints, which was extremely generous. Alright, so let's just go through. For example, the first letter here is a Y, which is shown right account. The Y actually is represented by W, and we can find other Y's and replace those with W's as well. Lots of W, J, M, I, R to start with for each of these. But we can go through and replace the others as well. Well, at least just the ones we know. Alright, so there's some C's. Let's move on to the H's. Well, it looks like that's about all they gave us, but we should be able to figure out what some of these other ones. Looks like the first word is watch. So M is T on the D's. So we can show that M is T. And then it looks like this is watch your. So that shows that C is a U and N is an R. And we should be able to fill in the rest of those as well. I got most of them. But in any case, you guys should be able to do, I guess, the rest of these. It looks like I missed a W, right? Yeah.
Watch your.
So, oh, and an O as well.
Watch your thoughts. They.
Don't forget, some of these now we should be able to tell, like D, that's thoughts, and U is an S. That should be a big help all by itself, just knowing what the S represents. Because all the U's can be replaced with S's. But we should be able to figure out the V's and the X's as well. It looks like I missed one too. Oh, and then you should be able to figure out what the X's and V's are. But just from this, you should be able to do that. So I'll let you guys finish it.